Okay, continuing on with our continuity facts. Even root functions are continuous where their arguments are continuous and positive. And that's the part we're really interested in here, and positive. So determine where this guy is continuous. And so this is going to be continuous where 8 minus 4x is greater than 0. And technically, I'm going to actually have to change this in the future. It should say and non-negative. Yeah. I was going to say non-negative, but we'll go with positive. So just ignore everything I just said there. Pretend that didn't happen. Where it's positive. Positive because of what we learned earlier, that we aren't doing square roots and negatives. And so when I have an even root, in this case a square root, but this is true for all even roots, I have to avoid imaginary numbers. That means I need to keep that inside positive. So I'm going to set this greater than 0. And if you put greater than or equal to 0, that's okay too. There's a little issue about 0 itself, about things being continuous from the left, right, two-sided. We aren't going to go into that. But if you put or equal to, I'm not going to care. Solving this guy. And then why I picked this particular problem. To remind you that when I solve an inequality and I divide both sides by a negative number, that inequality sign got flipped because we divided both sides by a negative. Got to remember some of those basic algebra things. And so we get x less than 2. So this is continuous for x less than 2, or you could say negative infinity to 2 with parentheses. If you had the or equal to, which I don't care about, if you had the or equal to, then it'd be a square bracket on that too. But again, we need that argument to be positive on the even roots because we're not using imaginary numbers. Okay, trigonometry. Determine trig functions are continuous on their domains. That's all the mathematicians give you. So you got to remember about trig functions. Now this one we're going to do graphically. Now graphically is not a perfect way of doing things, but good enough for our purposes here. So the following is the graph of y equals sine x. And so what? Pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, 1, negative 1. So it starts out at 0, goes to 1, goes to 0, goes to negative 1. Like that. And we'll put the negative 1 on the other side there. Then negative 1 and 0. And so there's my graph. And it goes on and on like that. We should all be familiar what the sine graph looks like. And so based on the sine graph, just based on what the graph looks like, it's continuous for all reals, negative infinity to infinity. And it's just best just to memorize that. The graph has no gaps, breaks, or holes, and we're just going to accept that as true. Same thing would be true for cosine. The graph of cosine, very similar. Cosine, continuous for all reals. Okay, tangent. Now you could graph it, but I think that would be the hard way. Let's view tangent as what we know it to be, which is tangent is sine of pi over 2. Sine of pi would be sine of pi over 2x, cosine of pi over 2x. So now it's a fraction. And so this will be continuous everywhere except where cosine of pi over 2x equals 0. Now I realize I didn't say this before. Go out a little bit. The reason why when we have fractions and we say everywhere except where the denominator is 0, the reason why we say that is because division by 0 is undefined. And so what you're finding when you find those denominators are 0, you're finding all the places where the function wouldn't be defined. And that's the first step in continuity. F of A is defined. And so in fractions, the first thing we look at is where things might not be defined. And so we look where those denominators are 0, and in any place those denominators become 0, we know we have a discontinuity because division by 0 is undefined. Okay, solving this. So trigonometry time. You're thinking backwards and you're asking yourself, where is cosine 0? And so you ask yourself, where is cosine equal to 0 in radians? Calculus is done in radians. And that will tell you what the angle has to be. So pi over 2x will be, and then you ask yourself, where is cosine 0? And doing bad notation here, cosine is 0 at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, on and on and on. So that tells me what pi over 2x has to be. Then I have to solve for x. And the easiest way to solve for x will be to multiply both sides by 2 over pi. And doing really horrible notation here. This, listing all these numbers with commas between them is horrible notation, but I think we all get it. So over here, the pi over 2 and the 2 over pi and the pi over 2 cancel, so we get x. And over here, all the 2's are going to cancel, and all the pi's are going to cancel. So I'm going to get 1/2, not 1/2, excuse me, the half canceled. When everything cancels, remember cancel is just division, so I've got, or here I'm multiplying, but still canceling. When you remember cancel, that's pi divided by pi, which is 1. 2 divided by 2 is 1. That when everything cancels, a 1 is left behind, and otherwise we get 3, 5, 7, and so on. And so I would be tickled pink by that. So it would be continuous for all reals except x equal 1, 3, 5, 7, ... I would be tickled pink by that, and that would be good enough. But the perfect answer here would be all reals except x equal 2n or 2n plus 1, where n is an integer. Now why that? 2n plus 1 is the way you denote odd numbers. Whenever you multiply something by 2, an integer, take an integer, 3, multiply it by 2, you get 6, it makes it even. But then when you add the plus 1, it makes it an odd number. So this would be an absolute perfect answer, that this would give me every single possibility of where it was continuous or discontinuous. But like I said, up here, I'd be tickled pink by that answer. And that's a good point to end this video.